Hello, this is Mr. Weideman, and this is Lafayette High School, Functions in Trigonometry. This is part 2 of our lecture on laws of exponents. And I'm going to pick up where I left off, and I'm going to talk about another rule. I think we had the product rule when we take exponents and multiply them, quotient rule when we divide them. See, what else did we do? We kind of learned what a exponent to a fraction meant, and negative exponents. That's right. That's a big one. Okay, here's a couple of rules. They're a little bit on the mamby-pamby side, but they're just kind of something you kind of need to know. Anything to the 0 power does not equal 0. That's a misconception. It equals 1. And this is kind of a favorite sort of example of kind of a gotcha question for Algebra 1. We have all this stuff, and, you think you got to do all this really, fancy simplification, and you're factoring, you're doing all sorts of weird trash. And right here, here's the gotcha. This whole garbage is raised to the 0 power. And, I've got this parenthesis, so that means all this trash in there is raised to the 0 power. Anything raised to the 0 power is simply 1. Okay? I can take a TV, raise it to the 0 power, 1. I can take a sad face, raise it to the 0 power, it's 1. It doesn't matter what the expression is. You raise it to the 0 power, it's 1. No exceptions. Okay, now there's another, it's very similar to the 0 rule, and it's called the identity. And instead of taking things to the 0 power, it's anything with an exponent of 1. And it just means it's going to be itself. And you just go, well, okay, that's not very tricky. But here's the tricky part. In mathematics, the default is 1. In other words, mathematicians rarely write 1. So if something has an exponent of 1, it looks like there's just no exponent at all. If it doesn't have a coefficient, or they don't write a coefficient, it means a coefficient of 1. So that's the thing that you have to watch out for. So here I have this big complicated expression. It's raised to the 1 power. What does that mean? Nothing. Okay, now here's what I'm talking about. Since these two are equal, rarely, if ever, are you going to see this exponent of 1. It's assumed, so it's not written. Okay, like for instance, x, if you just see x, you can assume it has an exponent of 1. And you can assume it has a coefficient of 1. But the mathematicians, when we write this, we're not going to write this. We're not going to write this. It's just going to be assumed. All right? So where does that cause a problem? Here's where it causes a problem. Let's say you have x, and you multiply x to, I don't know, x to the, let's make this weird. How about 3/2 power? Okay, well, what are you going to do? Well, here's what you have to do. You know that you have to add exponents. So I'm going to add, even though it's not written, it's assumed to be 1. So this is actually going to be x 1 plus 3/2. All right, common denominator 2. Okay, so this is actually going to be x to the 5/2. Okay, and the key is it wasn't written, but we have to assume that that 1 is there. All right? Okay, so the last exponent rule we're going to talk about, very important. Okay, we call this the power rule, and that is an exponent raised to an exponent. What's the rule? The rule is we just simply multiply. All right, now, you don't have to write this down, but what does all this garbage say? if this is raised to the fourth power. This is actually what it means. Z to the negative fifth times negative 2y squared z to the negative fifth plus negative 2y y squared z to the negative fifth. That's 3 times, one more time. Yuck. Man, that is awful. And so what do? Is I add the exponents. I add this, and I add this, and I add this, and I add this, and I get 8. And I want to cry. All right, so there's a shortcut to doing all of that. And the shortcut is here, I can just simply multiply this forward. It's like distributing, okay? Now, what I need to remember, just like we talked about in the identity rule, okay, we got to remember this guy right here does have an exponent. So what I can do is I can just distribute this 4 and multiply it to each one of these exponents. And that is my shortcut. And so that's 2 to the fourth, y to the 8, z to the negative 20. Now I've got to use my other rules. Okay, see this negative exponent? You know, got to take care of that garbage by sending it to the denominator. Y to the 8. Okay, now what about this guy right here? Yes, he's got to be taken care of also. Now, what is it asking? Is it negative 2 to the fourth, or is it negative 2 to the fourth? And they are different. Okay, well, which one of these is correct? Well, this one right here is the correct one. Why? Because this negative is inside this parentheses that's being raised to the fourth power. Okay? So it is actually negative 2 raised to the fourth power and not this guy. All right? What would make that right? This negative would have to be out here. Okay? And then we would have this situation. And I've got a big, huge mess going on here. Let's get rid of all this icky stuff that I did. Okay, so that's the answer. That negative 2 to the fourth becomes negative 2 times negative 2 times negative 2 times negative 2, which is going to give us the positive 16. All right, let's do another example. Okay, now what are we going to do here? I'm going to distribute the 3. But before I do that, let's do some simplification first. All right, I can use my other rules. I can go 17 minus 14 right here and get my a to the 3 using the rules that we talked out before. Okay, what happens to this guy? It's got to go to the numerator and become b to the positive 2 and combine with this guy. All right, so these are being multiplied together, a b to the 8, a b to the 2, add exponents, and that's how I get the 10. All right, now that is going to make things much cleaner and much simpler. Okay, remember this guy is to the 1 power, and then we just distribute that exponent to everything. And that's what we have there. Okay, so those are your exponent rules. Let's get to our homework assignment. All right, what do I want this homework assignment to look like? Okay, 1 through 61, every other odd. I want you to do these guys. 136 through 139 all. 136, 137, 138, 139. Okay, looks like a lot of work, but it's not nearly as bad as it looks. These are not super hard. Okay, what do I want? I want this header at the top of your paper. Let's do number 1 together. Okay, I'm going to write down the problem. I'm going to show my work, and then I'm going to box my answer, and I'm going to check it in the back of the book. Okay, you can be judicious here. You don't have to show every single little stinking step. All right, some of this can be done in your head. Do not use a calculator to do this homework assignment. It's counterproductive. All right, That's all I have to say about that. So good luck with your homework assignment.